Application development. In this chapter, we'll discuss application programs and user interfaces. Now, most database users don't interact with databases directly using query languages like SQL. Instead, application programs act as intermediaries, making it easier for users to interact with databases. Think of an app like Instagram. As a user, you don't have to type SQL queries to retrieve your posts or those of your friends. The app does that for you in the background, sending requests to the database, fetching the data, and presenting it through a friendly user interface. These application programs are often divided into three parts. Front end, this is what users interact with, like forms or web-based graphical user interfaces. A common example is a form you fill out when buying something online. Middle layer, this part processes user input and decides what to send to the back end. Back end, this part interacts directly with the database to fetch or store data. An example of an application that does this is a university registration system, where you input your course choices in the front end. The middle layer processes your choices, and the back end fetches available seats from the database. Application architecture has changed over the decades. We can identify four key eras: mainframe era 1960s and 70s. Back then, applications were run on large mainframe computers, which were expensive and used mainly by large organizations. All the processing and data storage were centralized. Personal computer era 1980s, as personal computers became more common, applications shifted to being installed and run locally. Think of software like early versions of Microsoft Word or Lotus 1, 2 to 3, which you would run on your home computer. Web era mid-1990s onwards, the rise of the internet meant applications could be accessed online through web browsers, which meant you no longer needed to install every piece of software on your computer. This is where many of today's web applications like Gmail or Netflix come in. Web and smartphone era, 2010 onwards. With the advent of smartphones, applications had to adapt. Now, many applications from banking to shopping can be accessed via apps on smartphones. They are often web-based but optimized for mobile devices. Consider online banking apps today. You no longer need to visit a physical bank or install heavy software on your desktop. You can simply use a web or smartphone app to check your balance, transfer money, or pay bills. The web interface plays a crucial role in modern applications. It allows users to access databases from anywhere, avoiding the need to download and install specialized software. Think about online airline reservations, university course registration systems, or shopping platforms like Amazon. You don't download the entire database or specialized software. Instead, you use a web browser to access a user-friendly interface. A significant advantage of this is the seamless experience provided by technologies like JavaScript. JavaScript, for example, runs in your web browser to make websites interactive. Think of when you select a product on Amazon, and the page dynamically updates to show related products without you needing to reload the page. This interactivity is powered by technologies that run smoothly in your web browser, creating a better user experience. Let's look at a basic example of how a web page can display data from a database using HTML. This HTML code shows how a web page can present data like an ID, a name, and a department in a table format. In the real world, imagine a university system displaying a list of students and their departments. The table structure in HTML allows us to display this information clearly in the browser. For example, a row in this table might look like this: ID 00128, name Zhang, department computer science. The HTML less thanable greater than tag creates the structure, and each less than or greater than represents a row of data. When you submit a search query, the application communicates with the backend database to fetch and display the relevant information. Modern web applications often follow a three-layer architecture. Presentation layer, front end. This is the user interface that the user interacts with, such as forms or buttons on a website. Application logic layer, middle layer. This processes the requests and determines what the user needs. Data layer, backend. This is where the actual data resides, typically in a database. Let's think of a web-based shopping system. When you search for a product, the presentation layer displays a search bar. The application logic processes your query and requests the product data from the database. The data layer retrieves this data and sends it back to be displayed on your screen. Unlike older connection methods that stayed open until the user logged out, HTTP, the protocol that underpins the web, is connectionless. After the server responds to a request, it closes the connection. This allows servers to handle more users efficiently, but creates a challenge when dealing with user-specific information like login credentials. For example, when you log into a website, you don't want to re-enter your username and password every time you click a new page. This is where sessions and cookies come in. When you first log in, the server sends a cookie to your browser, which stores information like your session ID. This way, the server knows you're logged in each time you make a new request. Cookies are small pieces of text that help identify and track sessions between the server and the browser. Think of it as a digital stamp that tells the server who you are each time you interact with it. For example, when you log into Gmail, the server sends a cookie to your browser. This cookie contains a unique session ID, so Gmail knows you're the same person when you navigate from your inbox to your settings. This mechanism makes online services much smoother to use. A servlet is a small program that runs on a server and handles user requests in web applications. When you fill out a web form such as booking a flight, a servlet processes the input, communicates with the database, and returns a result. For example, let's say you search for flights on a travel website. The servlet takes your input, departure and arrival cities, dates, etc., sends it to the database, fetches available flights, and displays them back to you in a user-friendly format. Here's a simple example of a servlet. This code fetches user input, like whether the user is a student or an instructor, and retrieves relevant information from the database. For instance, if the user selects student and inputs a name, the servlet will retrieve and display information about that student, such as their ID and department. If the user selects instructor, the servlet will instead show details about the instructor.